This is the continuation of the previous class. In previous class, we were doing pressure of physics. And as I told you in previous class, I told you that the pressure chapter I mapped into 15 different points. And we are dealing each of the point one after another. In last class, I told you about this upthrust and Archimedes principle. Today we are starting with law of flotation. What is law of flotation? A body floats on a liquid when it displaces the liquid equal to its own weight. This is law of flotation. And this much is not so clear to understand. That's why I want to explain a little more. Whatever it is, maybe very light body, maybe a piece of paper, or maybe a very big ship, or maybe a wooden piece, or maybe a plastic, whatever it is, if it is floating on water, then at this time it displaces the water equal to its own weight. A piece of paper, maybe its weight is 0.01 Newton, but when it floats, it displaces 0.01 Newton of water. In the same way, a piece of wood, let's say a piece of wood is of 10 Newton, and if it is floating, then while floating, it displaces water equal to 10 Newton. And let's say a big ship, its weight is, let's say, 1 crore Newton, and it floats on water when it displaces 1 crore Newton water. It means weight of a floating body is equal to weight of displaced liquid. Mathematically also we can write this. Weight of a floating body is equal to weight of displaced liquid. Now this is the law of flotation. How can we verify this law of flotation? Maybe one question, verify law of flotation experimentally. Now we are going to verify law of flotation experimentally, experimental verification of law of flotation. I want to show this with the help of diagram. With the help of this figure, we can verify law of flotation experimentally. After drawing this diagram, you can write this way. As shown in diagram A, an overflow can is completely filled with water. No more water can be added in it. And it is weighed. Let's say its weight is 10 Newton. And a piece of wood, let's say the weight of wooden piece is 2 Newton. When we place this wooden piece into water, then again the total weight, combined weight of wooden piece, water and overflow can is found to be 10 Newton as shown in diagram B. How it is possible? Because 2 Newton of wooden piece displaced 2 Newton of water which gone out through the spout. It means a floating body displaces the liquid equal to its own weight. That means the law of flotation is experimentally verified. After the experimental verification of law of flotation, now I want to tell you some reason question related to law of flotation. Let's start some of the very important reason question. Question may be like this. Look at this. A ship, number one, a ship immerses more in water when it is being loaded with cargo. What it mean? When a ship is being loaded with cargo, then it immerses more and more. We can explain with the help of this diagram also. Look at this. Let's say this is a ship and this is the level of water. When it is being loaded with cargo, then what happens? Now it immerses more. Now it immerses more. What is the reason? This was the previous level of water. Now it immerses more. Why it immerses more? We can answer this way. According to principle of flotation, weight of a floating body is equal to weight of displaced liquid. And when a ship is being loaded with cargo, its weight increases. And it has to immerse more in water to displace the weight of water equal to its own weight, and according to principle of flotation, it floats. This way we can answer. In the same way, let's talk about another question also, number 2. A ship slowly rises in water when it is being unloaded with cargo. This is just reverse of the previous question. Look at this. If the same cargo is being unloaded, then what happens? The ship rises slowly. The meaning is very simple. You have to start this way. According to principle of flotation, weight of a floating body is equal to weight of displaced liquid. If a ship is being unloaded with cargo, then the weight of ship decreases and it displaces less amount of water, less weight of water, which is equal to its own weight. That's why it slowly rises up. This way we can answer this question. Now I want to show you one simple experiment also that makes you very clear about this. Look at this. This is a metal piece. It seems to be, let's say this is a ship. It is made up of iron. When we keep it in water, then what happens? A part of it is immersed into water. A part of it is immersed into water. Very less part is immersed. And if we add something into it, I mean to say, I'm going to put some small gravels into it. If we put gravels into it, then what is seen? Look at this. The more part of it is immersed into water. Why? The reason is same as the previous question. Its weight is increased. Now, to float in water, it has to immerse more to displace the weight of water equal to its own weight. Now let's talk about third question. When a ship enters into the river from sea, it immerses more in water. When a ship, or we can say boat also, usually ship doesn't come to this river. Let's say when a ship or boat enters into river from the sea, then it immerses more in water. The reason is very simple. Sea water is dense water because salt is dissolved in it, but river water is less dense, salt is not dissolved in it. So in sea water, when it immerses less, the weight of displaced water will be equal to its own weight, and according to principle of flotation it flows. But in river, when it immerses more, then only it will be able to displace the water equal to its own weight. That's why it immerses more in river water than that of sea water. Now we can talk about another region question also. An iron nail sinks in water, but a ship made up of iron floats on water. This seems to be very simple, but to answer this question, it will be better to say about Archimedes' principle also. If we put a nail in water, then it displaces the weight of water, which is very less in comparison with the nail. And according to Archimedes' principle, of thrust is equal to weight of displaced liquid. So weight of displaced liquid is less and of thrust on the nail will be very less in comparison with the weight of nail. That's why downward force is more, it sink. But why a ship made up of same iron floats on water? We can answer this way. The ship is made in such a way that there is lot of blank spaces inside it. There is lot of blank spaces, hollow spaces inside it, due to which it floats. It becomes able to displace water equal to its own weight. Because of lot of hollow spaces, it becomes able to displace water equal to its own weight, and according to principle of flotation, it floats on water. Now look at this. A body having density more than water can be made to float on water. How? A body is dense than water. If a body is denser than water, it should sink in water, but it can be made to float on water. How it is possible? If it is converted to a shape in which it is hollow inside, or there is blank space inside it, then it becomes able to displace the weight of liquid equal to its own weight. It is normally made by raising its edges upward. A lot of blank spaces is left inside it, and then it becomes able to displace rho2 equal to its own weight, and according to principle of flotation it flows. This way we can answer different reason questions related to principle of flotation. This much for today. We will continue another class, the same pressure.